Data is like a waste table using the given data. It has
That is security and ethics.
Also, remember to hit the like button, subscribe, and share this video. Also, hit the bell icon for instant notifications for our next video. Now, let's get right into it. Hello there. Today, we're going to see Chapter 8 in our IGCSE Computer Science, the continuation. We're going to start with loss of data and data corruption. So, there are many reasons for data loss and data corruption, namely accidental loss of data, a hardware fault, a software fault, and the incorrect computer operation. Basically, you're not using your computer right. There are different ways to prevent slash damage control if these kind of things happen. For example, if you have accidental loss of data, to prevent these kind of things, you could try to back up your computer regularly and save your data. In case if you lose your data through an accident, you can get it back. Similarly, if there was a hardware fault, it's good to have a backup again, saving your data regularly and using a UPS so the hardware fault doesn't even happen in the first place if it's power related. Next, if the reason for loss of data and data corruption is a software fault, again, you can use your backups and save data regularly. Similarly, if you use your computer, the incorrect computer operation, you can use backups and you can teach a person how to use the computers properly. That is, correct training procedures. Next, firewalls and proxy servers. A firewall it basically sits in between the user's computer and the internet. So it acts like a traffic police officer. It basically inspects everything going between your computer and the internet. And this kind of thing is known as traffic. This information is known as traffic, sorry. Checking whether incoming and outgoing traffic meets a certain criteria that can be set based on needs. So basically, the firewall compares the traffic to a certain criteria, which can either be checking for spam or viruses or other stuff. And this criteria can be set up by the user. So basically, it inspects what's good and right and only sends the good to and from the computer. If such data fails to meet a criteria, that is, it might be spam or some sort of virus or some sort of malware, the firewall blocks the traffic. It logs all this incoming and outgoing traffic so that the user can inspect it later. So if something catastrophically goes wrong with your computer, you can inspect and see what happened wrong. So example, if something happened to your computer, you can inspect the traffic later. Again, it keeps a list of IP addresses and prevents certain websites from being accessed by the person because it saves them as dangerous because it might be a sort of malware might come from it and it's trying to protect your computer from all that kind of stuff on the internet while browsing the internet. It helps prevent viruses and hackers from entering the computer, as I mentioned before, and warns the user if a software tries to access external data. Basically, again, a type of virus that's trying to steal your data. Firewalls, basically, they have their disadvantages. They can't prevent people using their own modems to bypass the firewall, and they aren't able to control misconduct or carelessness. Basically, if you accidentally disable the firewall can't do anything about it. That's your fault. Users can also disable the firewall, leaving their computers open to harmful traffic from the internet. Again, restating the previous point. Basically, firewalls can do their job, but you have to allow them to do their job in the first place by not disabling them and not being careless around them. Proxy servers. Proxy servers are very similar to firewalls, and they basically act as an intermediary, as basically something in between the user and the web browser. Basically, the similar job to the firewall, basically filtering the internet traffic and blocking access to certain websites because, again, they might be dangerous. They also speed up access to information from certain websites by using cache, which is basically supplementary memory. So the advantage of cache is basically every time you visit a browser, some information on the browser is stored in the cache. Basically, the advantage of cache is that the next time you open the browser, it loads up much faster because it stored some information about the browser. Next, it also keeps the user's IP address secret, improving security. Basically, hackers can't find out your IP address easily thereby making it much harder for them to do anything harmful to your computer. Next. This is basically a visual representation of a firewall and a proxy server. As you can see, the firewall sits in between the user's computer and the internet. Again, the proxy server also sits between the user's computer and the web server. It's more localized, so to say. Basically, it acts as an intermediary, as said before. It acts as an in-betweener, a mid person, if you will. Basically, the user's computer sends a request, which is received by a proxy server, and the proxy server forwards the request to the web server. Then the web server says, okay, this is what I want. This is what the person wants. Send it back to them. And it sends a response to the proxy server, which then filters it and only allows the right information to go to the computer. Basically acting like some sort of mailman who's trying to filter out the bad things and only keep the good things and send it back to the user's computer. Middleman, basically. Next, security protocols. SSL, Secure Socket Layer. It's a type of protocol that allows data to be sent and received securely over the internet. Basically, it allows your data to be sent across the internet without being stolen or taken over by some external third party involving hackers or malware. To do this process, it basically encrypts your data when the user logs in. Only the user's computer and the web server are able to make sense of what's being transmitted. Basically, the user's computer and the web server have a certain encryption key that can be used to decrypt the encrypted data. Imagine the encryption of data is like putting a padlock or a lock on your door. Only the user's computer and the web server have the keys to open this lock and see what is inside, basically the information what is inside, in the case of computers. Nobody else can decrypt the data, hypothetically, because hackers can do anything, but it makes their job harder. Basically, the advantage of this kind of encryption is, even if the hacker gains access to this file or information, they can't understand what it is because it's encrypted. It's locked, basically. You will know if the website has an SSL protocol if they see a HTTPS or a small padlock in the status bar at the top of the screen. You can see why the padlock is referred in the image, because the whole protocol of SSL is pretty much similar to how a lock works in the first place. HTTPS stands for Hypertext Transfer Protocol over Secure. This is basically a visual representation of how SSL works. Basically, the web browser attempts to connect to a website secured by SSL. The web browser is basically what the client is using, and the web server SSL and asks the web server to identify itself. Basically, the web server is telling, hey, you web server, who are you? And the web server then sends a copy of its SSL certificate. Imagine the SSL certificate as your sort of ID, your driver's license, your passport. It's basically telling the web browser, this is me, I am the server, I am a reputed person, you can trust me. The web server then certifies or checks if the certificate is trustworthy. Basically, it's checking whether, okay, is this authentic, this is not fake, it's checking it. If the web browser completes this check, it then sends a message back to the web server. The web server will send a sort of acknowledgement back to the web browser saying, okay, thanks for accepting and checking through my SSL certificate. Now let's allow our encrypted session to begin. So now they'll transfer encrypted information to and fro. This is sensitive information, which is why it's very good for it to be encrypted. See, and then the encrypted data is shared securely between the web browser and the web server. So you don't lose anything and it's perfectly safe. TLS. TLS is similar to SSL in its working principles, but it's a more advanced version. Basically, it ensures the security and privacy of data over the internet. They're just providing the same functions, but better. How does it provide better? It's designed to provide encryption, authentication, and data integrity in a more effective way than SSL. Basically, it allows the authentication process of TLS is much better than SSL. Authentication, in turn, is basically seeing whether the data provider is a reputable source, to see if it's a trusted source. The same process happened in SSL as we've seen before, but it's more better and it's foolproof in TLS. Another advantage of TLS, transport layer security, is when a user communicates with the web server, It prevents third-party hacking. Basically, as you are sending a message to the web server, the TLS strongly prevents a hacker from obtaining this information while it's traveling, basically providing you even more security than SSL. Again, TLS is made up of two different layers. SSL was just made out of one single layer. So the two different layers in TLS are record layer, which basically holds all the data that can be transferred over the internet. This can be used with or without encryption. It then contains something known as a handshake protocol, which is basically the main advantage of TLS over SSL. The handshake protocol prevents the website and the user to authenticate each other and use encryption algorithms. It allows them to check each other if they are trustworthy or not, basically, to see if they are a reputable source even easier than normal. And then after checking each other, it allows them to use the encryption algorithms that come along with TLS. So this is an advantage that it's separated into two layers, because the hacker will have a harder time to break into both of them. Next, more advantages of TLS over SSL is it's possible to add new authentication methods to TLS. Basically, you can add on things to TLS, such as being able to add on different authentication methods to make the process harder. To make the process better, the authentication process better. Again, as I said before, it separates the handshaking process from the record protocol layer, which is an advantage because, well, if your hacker manages to intercept one, he can't get the other. It'll be much tougher job for him to get the other. Next, it makes use of the concept known as session caching, which we've explained back in the proxy servers as before. Similar concept, it's every time you visit a website, it caches some of the data. So the next time you visit it, the process is much faster. You can visit the page loads much faster. Next, encryption. Encryption is mainly used to protect data, as I explained before, in case it gets hacked. So even if the hacker gets your data, it's protecting it basically. It's acting as a lock which can't be broken very easily. Although it doesn't stop hacking, it can make the data meaningless to the hacker, as I explained. Basically, the encryption scrambles your data into a list of characters. It can be numbers, symbols, letters, and it makes it very hard for the hacker to break it because he doesn't have the key to break it, even if he gets the data. There are two types of encryptions: symmetric encryption and asymmetric encryption. Symmetric encryption uses a single secret key, which is basically a combination of characters. The key can basically be used to unlock the message, which will make it can be applied to a message, which will make it unreadable. Basically, you're locking the lock, unless somebody has a decryption key, which can be used to unlock the lock. Basically, decrypt the encryption, decrypt the message, basically, so that the person can read what it says, the receiver can read what it says. One key is needed to encrypt the message, and the other is needed to decrypt the message. So an encryption key and a decryption key. But in most cases, the encryption key and decryption key is usually one key to be used for the same purpose. One key can be used, the same key can be used for encryption and decryption. So the catch here is the sender and receiver must have the encryption and decryption key, which can be both one. So basically, the sender needs the key to encrypt the data, and the receiver needs the key to decrypt the data and read what was sent. So here you can obviously see there's a security risk. If the hacker gets the key, he can use it to decrypt the data and read what the message is. However, there is a way in which both the sender and the receiver have the required key without having to send it. So this kind of situation where the hacker can intercept the key and decrypt the data is known as the key distribution problem. So let's see how the sender and receiver can both have the same required key without having to send it to each other. So this is an example. A sender uses an encryption algorithm and chooses a value x is equal to 2. Similarly, the receiver also does this and he chooses a value y is equal to 4. X is put into an algorithm where you put 7 to the power x modulus 11. So we choose x as 2, so 7 squared modulus 11. Modulus basically gets the remainder of the value. So 7 squared is 49 and modulus 11. So you do division and find the remainder, and that's only the value when you do the modulus calculation. So 49 divided by 11 The remainder, the quotient is around 4, and the remainder is 5 because 11 into 4 is 44, and your remainder is 5. This number 5 is sent to the receiver. Similarly, the receiver has done the same 2 steps. He's applied the same algorithm, he's got a remainder value, and he sent it to the sender. Then they put their numbers that they've sent to each other. So basically, no, sorry. Yeah, they use the numbers that they've sent to each other. It's the same situation, except the base number, instead of 7 before, the sender uses the receiver's number 3 and puts it as the base, and then uses x, his number, and squares it, basically, as he's done before, modules 11, and then gets a number 9. Similarly, the receiver gets the number 5 from the sender, puts it as a base instead of 7, puts the power y number he already got, so 4, 5 to the power 4, mod less 11, he got 9 again. So you can see here that indirectly they've transferred 2 numbers to each other and managed to get the same number in the end. In this way, if they keep doing it, they can end up getting encryption keys with each other, and this key can be used to decrypt and encrypt messages. So this is just an example of how people can send data to each other without having to send the actual data, rather sending different numbers to each other, doing a calculation, and getting the same data in the end. So let's see asymmetric encryption. Asymmetric encryption is a more secure encryption method. It uses 2 keys, a private key and a public key. So let's see how the process works. User A uses a symmetric key, which is the key we just learned before, to encrypt the message. Okay, so single protection. The symmetric key is again the symmetric key. You've encrypted the key again using something known as a public key, which is known to both users A and B. User A sends the message to the B over the internet, securely protected by 2 steps. The symmetric key was used to encrypt the data, and then the key itself was encrypted by a public key. User B uses a symmetric key of their own, which is just a normal symmetric key as we've seen before, to decrypt. User B uses a private key to decrypt as the symmetric key, which came with the data. He then uses the symmetric key that he's decrypted to decrypt the message. So as you can see here, there's 2 keys, public key and a private key. So every user on the internet has a public key and a private key assigned to them. A public key will be known to everyone, basically the user and the people who want to send data to him. But the private key is only known by the user. So basically, the public key can be used by anyone to encrypt the data and send it to the receiver. But the receiver only has the private key, which means only the receiver can decrypt the message, which is defined with that public key. So you have to recognize that public key can be used to encrypt the data, and for that encrypted data by that public key, only that private key that only this receiver has can be used to decrypt that data. Here you can see that there are double protection by using a key to encrypt the data and then encrypting that key. Next, hashing. Hashing is used to verify data, as a hash can't be reversed to get the original message. Basically, hashing is a better form of encryption, where it basically makes your data into a very long string of numbers, characters, and symbols. For example, a password stored on the database, but as a hash, password can be stated on the database as a hash. The user enters the password to log in. The password is then hashed and compared with the stored hash. If they match, access is granted. If they don't, access isn't granted. So basically, it's used to, so you get a certain data. It is then hashed. It is then compared with the hash on an original database. The advantage of hash is it can't be reversed to get the original message, so it's only used for a verification purpose. So this is plain text and ciphertext. It's basically in the context of encryption. Plain text is the normal information, saying like, for example, hello. And then when you apply the key to it, the encryption key, it turns in encryption key along with it, and then putting it through an encryption algorithm. It then encrypts the data, turning it into a form of ciphertext. So my hello, along with the encryption key and encryption algorithm, turns into a B dollar symbol 125 something, which can't be identified or made sense of by the hacker. This is the end of part 2. The rest of the content will be explained in part 3. Thank you for watching. Stay tuned on Code for more videos.